Hello, hello, minasan, mambo desu. So today let's continue with dynamic programming problems. Yeah, so today's problem, the first problem is rectangle cutting. We are given an okay, so we are given an A times B rectangle, and we need to cut it into squares. On each move, we can select a rectangle and cut into two rectangles in such a way that our side length remain integer. So what is the minimum number of moves? Okay, so first let's visualize. So we are given a rectangle here, and we can cut it anywhere horizontally or vertically. Yeah, and after cutting, we have after first cut, we have two rectangles, and now we need to keep cutting until the rectangles become squares. So here let's try. Yeah. Okay, so we kind of get it here. So for example, we have a rectangle length 3 and 5. So we can make the 3 and 5 can become the 3 and 2 and 3 and 3. So we have the 3 and 2 left, so we can keep cutting it into 2 and 2, 2. The 3 we can cut to 2 and 1. So we have another rectangle called 1 and 2, and the final cut we just divide the 2 into 1 and 1. So in total, first, second, and third, so total 3 cuts. 1, 2, 3. Okay, so incidentally it is the optimal move. Now let's go with a bigger problem. Oh, and I just realized it is like the lowest Okay, so it decides find the rated common divisor. So we keep iterating to find the rated common divisor of the rectangles. So okay, so let's try with a bigger number like 15 and 23. So here we can cut into 15 and so it can be cut into 15 and 8. So 15 and 8 can be cut. Keep cutting. We have 15 and 8. Okay, so let's start the timer. Yeah, 15 and 8 can be cut into 8 and 7. So 7 and 8. Can keep cutting into 7 and 7 and 1. So we have 1 and 7. This one we need 6 cuts. With 6 cuts. So the total is 6, 7, 8 and 9 cuts. 9 cuts doesn't seem optimal. So how do we find the optimal choice here? Okay, so we need to try all the ways to cut the rectangle into smaller rectangles. Okay, so okay, so let me think. Okay, so we just try all the possibilities, like from 15 and 15 and 23, and we can cut 1, 2, 3, 4, 5, 6, 7, 50. Yeah. Oh, I actually there's 1 until 7. Here is 1 until 11. Okay, so there for each choice we can create a smaller rectangle. And once we cut, we have other rectangles. We create more rectangles. So okay, so I think we can create a table of optimal of the minimum number of moves for rectangles here. So we have 0. The length and so the width and the height. So for 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5. This. So all of these, this like 0 moves. And for one, okay, so we remove this guys. Okay, then let's just take this guys. So from 2 to 1, we need to cut it into 2. We can cut it to 1, 1. So to create 2, 1, 1. So 1 moves. And 3, 1. We can have many choices. Okay, so with 3, 1 we can turn it into A plus B 1. So we just need to find the optimal A and B. Okay, so this table is a number of cuts to create squares. And okay, we can build up from 1, 1 until the maximum value. So from 3, 1. We can divide it into 3, 2 and okay, so for x case we can trace back to the base case. So the 3 can be turned into 2 and 1, just that. So it is 2 and the 4 is 4 actually can be turned into 2 to 1, so 1, so it takes 1 move to convert this into these states. For the 4 case we can cut it into so for 1 we can cut to 2 ones and keep cutting, so total is 1 to 3, or we can cut into 4. For 1 we can create a 3 and 1 1 and 2 and 1 1, so it's still okay. So this is 3 minimum 3 cases, and then we build up from the next case. Here is 3 2. We can turn it into the base case like 1 2. One, 2 and 2 2. Okay, so we just build up and build up and up and up until we reach the desired DP state. Okay, so we need the maximum of A and B is 500. So okay, so time complexity is O A B, and for each we can for each A, when we are at an A and B width, we need to divide the A into we try all of the combination 1 2 3 4 5 6 7. So try A, half of A combination and half of B combination, so the total is at A plus B, like this, around this. So okay, so min max of B, so let's treat A and B and means min max of B is an N, so total is N cube, time complexity is N cube, and with N equal 500. So we have a total of 1 125 million operations, but actually we don't use that many operations since we just take half of that, so 250 cube. Cube 250 cube. And the total is just roughly 15 million operations, and it's fast enough. Okay, we can try it. Let's do it now. Okay, so we build the optimal number of cuts, and we try from the next value we try all of the previous cuts to find the optimal. Okay, so let's take the integer a and b. So first we build a DP array. So let's create a vector, and let's go and the size of the DP array equal to max of A and B. Vector in DP type n, and vector in also type n. Default value is 0, and we build up the DP array. So for I equal to 1, I plus 1, I plus less or equal than n, I plus plus. For in z equal to 1, z less or equal than n, I plus plus. So if I equal to z, then continue. So the minimum number of moves is 0. Otherwise, actually we don't need to, we can just skip all the less or equal than this. This should be enough. Yep. mean that's a very high number. So at the end, dp I say equal to dp equal to cuts. So we need to find for in k equal to 1, k less than n, k no, k less than I divided by 2, k plus plus so return dp I p. Equal to min cuts dp I plus k and z plus dp I plus I minus k z and I minus k z plus 1. Yep. And next is the other edge. Z minus k. Yep. And I think this should be the O. Yep. It's simple. We build up the DP array and we find all the possible. We find the optimal number of cuts from the previous arrays. Yeah, and I think I can submit this. Let's try it. Come on. Oh, accepted. Too simple. I might be a master of DB. Haha. Okay, so let me upload my solution. Done the first problem of today. Next is the second problem. Palindrome query. Oh shit, I forgot to stream my code. Shit, sorry. Very sorry. Sorry. Okay, so let's go to the next problem. Oh, sorry, I forgot to turn on my mic. So let's go to the next problem. Palindrome query. So now we are given a string of length n, and there are q queries, each of the form left to right. So we need to determine if x. Okay, so a query x query select a segment, and we need to a segment, and we need to determine if that segment is a palindrome. Okay, so for a string of length, the length of the string is 2000, and the query is 10 to the power of 5. So we need to, I don't know, let's think for a bit. So let's draw the string A, B, C, P, D. So for the string 1 to 3, okay, so I will not want any additional complexity. So I think we should calculate the array of palindrome. So for the value left and right, then determine if it is a palindrome. So 1, 2, 3 ABC is not a palindrome, and 2 to 4 CB D 2 to 4, okay. 2 to 4 is a palindrome BCB. Yep. Okay, so we create the array. I think we can build up the array here. So if a string is a palindrome, then when it expands to the left and to the right, it can also create a palindrome too. Okay, so a palindrome, it has a center, and everything to the left and to the right are the same. So okay, in this case, if we start with the letter A, and it is a palindrome, yes. And if we start with B, AB isn't a palindrome, but B is a palindrome. Okay, so we can combine a palindrome. Okay, so for a value to be a palindrome, then its left and right must be a palindrome. Yep. Okay, so let's try this approach. Let's say this center. Okay, so the dimension first is the center location. Index. Center. Index. The index can be from 1, 2, 3, 4, 5. Yep. And next is the expansion. So there is a length, array length. If the length is 0, then we can just take the center. If it's odd, then we the length is 1, 2, 3, and 4. So all the string with length of 1 is a palindrome. Yes. So let me use different color. Yes. And next is the length 2. Then we need to check the left and the right of the circle. Left and right of the center. Okay, so if the center is 1 and length is 2. Okay, so it's too complex. Let's separate it into 2 different cases. So in the left-right length. So okay, so for the odd string here, odd length string here. Okay, so x of the length 0 is a palindrome. Yep. and next ABCBD. If we expand, there are certainly values that cannot expand. So position that cannot expand, yeah. Not. So we check the long one here. From the position 2, you can check the left and the right. First is we check the previous is an palindrome, yes, and okay, then we check the left and the right. If it is a palindrome, then yes. From the position 2, is it not 3? Yes. Okay, we continue the checking. Nope. Yes. No. Okay, we're done with it. So we create a DP array. Two DP arrays. The check palindrome. So okay. So we can calculate the. Okay, I think I get it. But okay, let's dive into coding right now. Go. So first let's take a string and integer number of queries. Nope. Once we have this string, we set n equal to the dot size. And we create two palin. Okay, so we create two vector. First the vector in dp odd, the odd case here. So it has two dimensions. Dimension one is center index, and the dimension 2 is the length from center extending from center. Okay, so we can only expand at most. We have one here, so we can expand unit. Let's expand. Extend this and round down by 2 half a pen and divided by 2, so if yours in the center index can be n and vector boolean max extend 4. Then we populate the DP, right? And here you got 0. Let's saw it less than n I plus b hot I 0 equal to, and next we populate the next I equal 0 I less than n I plus z equal 0. No, we need max extend. Yep. Z less than n, z plus. So the DP so if DP on -1 z, if it is in the palindrome, then we can skip. Equal z minus I less than 0 or z plus 9 greater than and equal then DP hot I z equal it's Thursday. Yep, that should be the first DP. Alright. Okay, and next is DP event. And max extend. Actually, let's use this. Even extend and then yep. TP cell equal to max extend I minus 1. Yep. So we can here is also the max extend. Yep. So for I equals 0, max extend over 0. No, I equal to 1. Maybe odd over my sense 1 equal DP SI equal to S I plus 1. Yeah. Minus 1. Next extend is the max extend is from 2. Yeah. They equal 0. plus 1 less than 0, plus 5, yep, greater than n. I minus a plus 1 I minus I plus a, yeah, be even. Okay, so we have the, so now we need to convert the, right, takes the number of queries. We for loop until query all queries. So in left and right, it takes the left and the right value. Okay, so if right minus left, plus 1 is divided, can be divided by 2. Equal 0. Even not first. And we find the center by taking left plus right divided by 2. Yep. And center extend equal extend one, then minus plus 1 divided by 2. So if 1 no. Okay, this is one base index, so we need to minus here and minus so 0 plus 1. Yep, center is okay, 0 and 1. Okay, still correct. Yep. Now one extend is DP on. Extend center. To select it, all right. Even non-DP on. This one. Okay, so we can extend. So if the string length is 3, then we can select a center and extend by 1. Yep. Okay, extend is correct. Go by the max extend. Oops, wrong here. Okay, we need debugging skill here. Lay minus 9 less than 0. Z minus I, Z plus I. Plus 1. Okay, so we have got the correct answer, I think. Let's try it. Oops. Six, seven. So 6 plus 7 is 6, and the extent is 7. Okay, so left 2 and 1 and 3. And here we need to plus 1. Yeah. Okay, extent is yeah, we grade 2 arrays. Is correct. Yep. Not pretty, but it's a working solution. So we need to handle both cases of a palindrome. One is a palindrome with odd size and palindrome with even size. So okay. complexity is a valid solution. And I just check with Gemini and just found there is a algorithm called Manager's algorithm, and it looks very tricky to implement and to understand, but okay, so just like that. Consider that we don't know that algorithm. We can just build our own logic by expanding around the center and divide it into two cases. Yeah, the DP on and DP even, and we achieve a time complexity of n square, and space complexity is n, also n square. But we can optimize it to n by just taking the current array and the previous array. And yeah, people have different implementations and they all look weird. Holy shit, I think I just saw someone hashing the entire string. Yeah, it is a valid solution, but yeah, let's stick with our DP expanding from center. And yeah, this should work. And let me upload my solution. Is easy to understand, yeah. That okay, that's all for today. Thank you for watching. Bye bye, see you tomorrow.